Ever since we first looked up at the night sky and wondered what those tiny points of light might be, one question has echoed through the ages: are we truly alone in the universe? It's a question that predates modern science, stretching back to ancient philosophers who speculated about other worlds and possible life beyond our own. But today, for the first time in history, we're beginning to answer that question not with poetry or myth, but with data. In just the last 2 decades, astronomers have cataloged over 5,000 confirmed exoplanets, worlds orbiting stars far beyond our own sun. And this is only the beginning. Thanks to missions like Kepler, TESS, and the James Webb Space Telescope, we've developed a sweeping census of the Milky Way galaxy. And here's what we've learned. On average, every star you see in the night sky has at least one planet orbiting it. Let that sink in. Our galaxy alone holds around 100 to 400 billion stars, and if each has at least one planet, we're talking about hundreds of billions of planets in the Milky Way. Even more astonishing, roughly 1/5 of those stars likely host Earth-sized planets in the habitable zone, the narrow band around a star where liquid water could exist. That means, statistically speaking, there could be tens of billions of Earth-like worlds in our galaxy alone. But it doesn't end there. Look farther. Through the eye of the Hubble Space Telescope, we've glimpsed over 100 billion galaxies in the observable universe. Each galaxy, like ours, teems with billions or even trillions of stars, each with its own planetary system. When you multiply those numbers, 100 billion galaxies times 100 billion stars, you're left with a figure so vast, so utterly beyond comprehension, that it stretches the limits of human imagination. And yet, despite this staggering abundance of worlds, we still don't have a single confirmed signal, photograph, or sample of extraterrestrial life. So we ask again, are we alone? Or have we simply not looked deep enough, or long enough? The deeper we dive into the cosmos, the more confident we become in the numbers. The math is overwhelming, the probability is high, but there's one problem: where is everyone? This haunting question, famously posed by physicist Enrico Fermi, cuts through the optimism of discovery like a blade. It's become known as the Fermi Paradox, the contradiction between the high probability of alien civilizations and the deafening silence of the universe. With billions of habitable worlds out there, logic suggests that even a small fraction of them should harbor life. Some of that life, over billions of years, should have developed intelligence, technology, and curiosity, just like we did. Given enough time, those civilizations could have explored the stars, colonized nearby systems, or at the very least, left behind detectable signs of their existence. And yet, nothing. No radio signals, no alien spacecraft, no strange artifacts drifting through space. The universe is not just quiet, it's eerily quiet. Why? There are many theories. Some scientists believe intelligent life is extremely rare, that while microbial life might be common, complex, tool-using organisms may be flukes of evolution. Others suggest intelligent life inevitably self-destructs, annihilating itself with war, climate collapse, or runaway artificial intelligence before it ever reaches the stars. But there's another possibility, just as sobering: maybe we're simply not listening correctly. For decades, we've been scanning the skies for radio signals, looking for a cosmic version of Morse code beaming across the stars. This approach, known as SETI, the search for extraterrestrial intelligence, has yielded no confirmed detections. But maybe that's the wrong strategy. Think about how much human communication has changed in just the past century. We've gone from massive radio towers to laser communication, fiber optics, and quantum encryption. Most of our modern transmissions are compressed, directed, and quiet, invisible to anyone who isn't specifically looking for them. If alien civilizations evolved past radio centuries ago, we might be searching for signals that no one is sending anymore. That's why scientists are now expanding the search. We're looking not just for messages, but for technosignatures, evidence of advanced technology that could be detected across space. This could include gigantic solar arrays collecting energy from a star, atmospheric pollution on exoplanets caused by industry, thermal signatures of artificial megastructures like Dyson spheres, or even unusual motion patterns of spacecraft not obeying natural physics. These traces might be more subtle than a radio ping, but they could be just as revealing. And with new telescopes like the James Webb Space Telescope, LUVOIR, and future observatories, we're now equipped to examine alien worlds in greater detail than ever before. We're not just listening anymore. We're watching. While the search for alien intelligence continues, some scientists are focusing on a more modest, but perhaps more achievable, goal: life itself. Not warp drives, not radio signals, just life. And in this search, the possibilities are growing every year. We now know that certain gases, like oxygen, methane, and phosphine, can act as biosignatures. If we detect these gases in the atmosphere of a distant exoplanet, especially in combinations that don't occur naturally without life, it could be a powerful indicator that something is breathing, growing, or evolving on that distant world. In 2020, astronomers detected phosphine in the atmosphere of Venus, a planet long considered too hostile for life. The discovery was controversial and remains unconfirmed, but it reminded us that life might exist in places we once overlooked. Take Europa, one of Jupiter's moons. Beneath its frozen crust lies a vast subsurface ocean, kept warm by tidal forces. The same is true for Enceladus, a small moon of Saturn that blasts water vapor through geysers into space. These hidden oceans might be teeming with microbial life, protected from radiation and surface extremes. Mars, too, remains a candidate. It's dry and barren today, but ancient riverbeds and seasonal methane releases hint at a potentially watery past, and maybe even a biological present. So maybe the first sign of alien life won't come from a distant star system. Maybe it will come from just a few planets away. But if intelligent life is out there, technological, capable, even advanced, why haven't they reached out? One unsettling theory is the Great Filter, the idea that somewhere along the path from simple chemistry to interstellar civilization, there's a barrier, a step so difficult that most life never makes it past. The filter might be behind us, meaning we're rare survivors. Or it might lie ahead, suggesting that most intelligent life destroys itself before escaping its own planet. Another theory is more philosophical, the zoo hypothesis. Imagine an interstellar civilization that's millions of years older than us. What if they know we're here, and they're watching? Just as we study wildlife from a distance, what if alien beings see us as a primitive species not yet ready for contact? They may choose to observe silently, avoiding interference until we're capable of understanding or contributing to a broader galactic community. It's not science fiction, it's one way to resolve the paradox, an explanation for the silence without assuming absence. And then there's the most human answer of all: maybe. We're just early. The universe is 13.8 billion years old. Our species has existed for less than a blink in that timescale. It could be that intelligent life takes a very long time to emerge and find each other. We might simply be the first, or among the first, explorers stepping out into a vast and still silent galaxy. Even if we never receive a message, even if we never find a fossil beneath Martian soil, even if every signal returns static and every telescope shows lifeless rock, the search itself still matters, because it forces us to ask, what does it mean to be alive in this universe? In looking outward, we learn more about ourselves, our fragility, our brilliance, our responsibility to this tiny blue world we call home. And make no mistake, the tools are getting better. Within this generation, new missions will launch. Telescopes capable of peering into alien atmospheres, spacecraft designed to return samples from Mars, probes that could one day explore the oceans beneath Europa's crust. Each mission brings us one step closer to answering the oldest question ever asked. Will the answer change everything? Maybe. Imagine the implications, cultural, religious, scientific, of proving that life is not unique to Earth. That intelligence is not ours alone. It would transform how we see our place in the cosmos. It could unite humanity, or challenge it, but perhaps the real discovery won't be about aliens at all. Perhaps it will be the humbling realization that the universe doesn't revolve around us. That in a cosmos filled with billions of galaxies, we are not the masters of creation. We are one fragile species, just beginning to understand the scale of what's out there. Still, what if one day we hear it? A faint signal, a repeating pattern, a voice, not ours, reaching across the stars. That single moment would split history in two, before contact and after. And the universe would never feel empty again. Until then, we listen, we explore, we wonder, because the silence of space isn't proof of absence. It's an invitation, and maybe, just maybe, someone out there is listening too.